Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see, as I mentioned in previous video, that we will see numerical in next video. Okay, so we will see numericals in this one. So this is the first part of the numerical. Okay, so let's see the question. Calculate the shear stress distribution at the built-in end. Already that we had seen the derivation for built-in end of the beam shown in figure 1. So here figure 1 is there. In this, for this figure, we have to find. When at this section, it carries a shear load of 22,000 Newton acting at a distance of 100 meter from the parallel to side 1, 2. So just see, here is 1, 2. So at a 100 mm distance, this 22,000 Newton is acting. The modulus of rigidity G is constant throughout the section. So for all the section, G is constant. So dimensions are given. So now just see here. That is not after drawing the shear stress, that is there. So from 1 to 2, so that's why the shear stress distribution will be like this, Q 1 to 2. So from 2 to 3 in this direction, 2 to 3. From 3 to 4 and then 4 to 1. So finally reaching to 1. So what we will do, we will take reference or origin, you can say, at point 1. One more thing in this is the given this angle theta. Okay, that you have to take care here. That angle theta, that has 30 degree. And the thickness of this one, right, as 1 mm is throughout, the thickness is same for all the beam, right? 1 to 2, 2 to 3, 3 to 4 and 4 to 1, no, sorry, 4 to 1 is 0.1 mm, not same is there, it's a given, different. So 1 to 2, it's a 1.6 mm thickness is there. For 2 to 3, thickness is 1 mm, and for 3 to 4, thickness is 1.2 mm. So these things are given in the question. So now we have the thickness of all the sides, shear stress, how much it's applied, that shear load, that also we have, and in this figure you can see the how the shear stress will be there, right? So based on that only we have to calculate what? The shear stress distribution. Okay, so now come to the solutions. So again, what is there here? Sign convention is important. Okay, that we have to take care of sign convention. Now the shear flow Q at any section of the beam is given by, so Q equals to GT into P d theta by dz. So for that area, home area, du by dz into cos phi, that velocity along that u direction, that is along y direction, cos psi. For again velocity in y direction, dv by dz, sin psi, and then finally this one, del w by del s, the final wrapping area that is there. So at the built-in end, once its end is there, that is closed, that already we have seen this one. So del ws is 0 and hence this term will not be there. So after writing this again, Q equals to G into T, no, after that P d theta plus du by dz cos psi plus dv by dz sin psi. So this will be our main equation. From this only we will solve. So now what we are doing, instead of writing d theta dz, okay, du by dz, dv by dz, just we are writing, later we will see that for this we are writing d theta dash, du dash. So d theta by dz as theta dash, du by dz as what? So whatever u is there, so u dash. Similarly dv by dz as v dash. That we will use so that it's just look like simpler. That's all. Okay, so in which dy by dz, okay, du by dz, sorry, this is d theta by dz, du by dz and dv by dz are the unknown. So these things are unknown, means that we have to find. The remaining terms being function of section geometry. So this sin psi, cos psi and p, these are the dependent on the geometry. So that's why here just see the value is given, that is 30 degree. Now what we required, again the sign convention, this figure already we had seen. So this is 0 to this one origin, that generator is there, P. So here this angle is given like here, that psi. This is psi, right? This is the shear as positive anti-clockwise. Already we had seen that anti-clockwise positive, and along this Q also will be positive. So just see here, this is V, this is U. right? So in terms of z we are finding, that's why we are taking v and u only, not along the z axis, whatever the velocity is there. So similarly, if suppose we will find for the along y axis, then here this will be dy, and dy. That time we will take velocity along x axis and velocity along z axis. So but now we are taking along the z axis moment and all, so that's why that velocity won't be there. Only x component of the velocity and y component of the velocity will be there. Okay, so it is helpful at the start of the problem to escape the notation and sign convention as shown in figure. So that sign convention already we discussed. So here, like this, it's a moving. So anti-clockwise means we are getting the positive. The wall of the beam are flat and therefore P and C are constant. So it's flat, means their thickness is not changing, right? And no, this one is there, so means P and C are constant along each wall. So all the walls having P and C are constant. Also, the thickness of each wall is constant, means whatever the value is given, right? 1.6, so means from here to here, that is 1 to 2, that is throughout 1.6. For 2 to 3, it's throughout 1 mm. For 3 to 4, from here to here, it's 1.2 mm. And for 4 to 1, throughout, it's 1 mm. Means thickness also is constant for all that particular beam, from where to where that thickness is there. Okay, so that the shear flow Q is independent of S in each wall. So now Q does not depend on S. Let point 1 be the origin of the axis. Now, earlier also told, so this will be our reference point. So here we are taking that as this point as origin. Okay. So now, just I earlier also told, so for theta, that dz, d theta by dz we are writing theta dash, du by dz u dash, and dv by dz as d dash. So now just substitute. We obtained from the above equation. Which equation? After substituting in the previous equation. Okay. So this one. Okay. Now just see for this one, the first equation 1 to 2. I'll just see first this equation. So like Q1 to 2, 1.6 GV dash. So here this equation is there we have. So for 1 to 2 we are finding G will be there, T will be there, right? Now, so in this what will be there? So this psi, there is no angle for this one. So 0. Here also psi, that also won't be there. Only this term will be there. So Q1 to 2 will be equals to G into T, okay, and P d theta by dz. Sorry, right? That is here. Well, this will be, okay. P will be 0 in this case, that is given, right? So du by cos. So just see, this is parallel, right? So angle is 0 degree. So put that value here. So d theta by dz also is 0. So g t into 0 plus du by dz into cos 90 plus dv by dz sin 90. So sin cos 90 is 0. This term will be also 0. So gt into sin 90 into dv by dz. Okay. So t value is given for this one 1.6. So after substituting here 1.36 and dv by dz is what? V dash. So just simply V dash. Okay. Now for 2, 3. So just see here for 2, 3. Okay. So for 2, 3 you can see their angle is there at 30 degree of this one. Right. So just that we have to put, means this time this also will be there, this also will be there, and this also will be there. In which direction we are going? For 2 to 3 at anti-clockwise. So first for that one for positive and V will be negative in that case. So just here. Okay. So here 375. That area is given in the question. Okay. Okay. This part is given for which one we are finding. Okay. And into 0.866 theta dash. This is so cos psi and theta dash minus this one is for 0.866 u dash, that value of cos dash, and then same value for v dash. So this is for Q2 to 3. Okay. In that case 2 to 3 thickness is given as 1. So 1. Now Q3 to 4. Okay. Now for this one 3 to 4. Again For that 500 is given for that area of right into 0.0886 Q41 is there. So after that minus 500 into Q 0.886 Q23, and for that equilibrium that should be what? Equals to 0. And Q41 is again what? Q41 is this vertical one, right? So here Q41. So again this will be only there, U dash will be there. Here V dash and P will be equals to 0. So now after that what happened? Once we will simplify these equations. So first we have these 4 equations, right? Next take the moment. Okay, so for horizontal equilibrium, right? So all the horizontal force should be equals to 0. So after getting this horizontal force equates to 0. Okay, now what we will do, just see Q41 and Q23 from figure. Q41, right? And Q23, once we will resolve this one. So that should be equal. Right, so just equate that one. So Q41, what is Q41? This value. Right? What is Q23? This value. Right? Just equate it. So after equating what we will get? Q41. So I'm just writing. So Q41 is 1.0. Sorry. 1. Okay. This one. 1.0 GU dash. That is our Q41. And then Q23. What is Q23? This whole thing. So that is equals to 1.0 G into 375 into 0.886 theta dash minus 0.886 U dash minus 0.5 B dash. Right? This is our Q23. Now after further just multiply and expand. Okay. So after simplifying what we will get? Okay. This one. And next equation is for the vertical equilibrium. Okay. So vertical equilibrium, all the vertical forces should be equals to what? Whatever the vertical forces is acting. So just see in the figure how much vertical forces is acting? That 22,000 Newton. So just equate to 22,000 Newton along that all the vertical forces. Okay. So now after equating we will get this equation. So now we have 6. Next for moment equilibrium about point 1. Now along the point 1 already we are seeing here we are taking as origin. So now along this origin we will take the what? Moment. Okay. So after taking moment about point 1, whatever the area is given, that is given 500 into 375 into 0.086 Q23 plus area of this one is given that figure, or you can just refer the book. Actually I missed this area, that lengthwise it's given. Okay. So 500 for this part is it's given 125 into again 500 into 0.886 Q34. That is equals to how much? 22,000 is there, that force, and into perpendicular where it's acting at 100 mm. So that's why this 100 mm. Okay. So from here. So now after this, after simplifying this one, we will get 3Q23 plus Q34. So just here Q34 is the once you will simplify, just multiply 500 into 375. Okay, into this term Q23. So just see, I'm showing individual term. Okay, so first I'm showing so this one. So 500 into 375 into 0.886 Q23. If you will multiply this, then you will get 3Q23 from this term. Next, if you will multiply 125 into 500 into 0.886 Q34, then you will get what? Just 1. So that is Q34, right? So here Q34. Now just after, so just after multiplying and simplifying, okay, you will get this value after simplifying and just multiply. Some coefficient will be here constant, right? And here also 3 into something will be there. Take that common and divide this side. So after that you will get 40.6, right? So now that we have 7. So now after getting all the equations, here it's a important things you have to remember what and where to substitute. Okay, so means what value and where you will substitute. So just see for that only this is there. Substituting for Q12 and the like from equation 1, 2, 3 and 4. For 1, 2, Means from equation 1, 2 and 3, 4. From these 4 equation, we have to substitute in equation 5, 6 and 7. So from here Q12 is 1.6 GB dash. So substitute in fifth. No, that is not this one. Where is the Q12 dash? Here. Okay, and here. So substitute here this value. So after that, what we will get? Substituting in fifth and sixth. So in sixth, Q12 is there, right? In fifth, Q12 is not there. Or just first substitute in fifth. So Q41 and Q23. What is Q41? Here. And Q23 here. So this equals to this one. Directly we can add that earlier also. Or just let's substitute once again. So Q41 is 1.0 GU dash, right? That is equals to what? Q23 1.0 G into 375 into 0.886 theta dash minus 0.886 U dash minus 0.5 V dash. So this will be our one equation. So after substituting which one? 2 and 4 in this equation in 5. So because 2 and 4 only is required from this one. Next in this equation, what is required? Q12, Q34, Q23. So just substitute all here. Q12, that is there. So now I'm writing for substituting in sixth one. Okay. So now in sixth one. So 375 into Q12. What is Q12? Here. So into 1.6 G V dash. So this term completed. Minus now 125 Q34. What is Q34? This total. Right. So into what? 1.2 G into 500 into 0.866 theta dash minus V dash. Right. So this will be after substituting this term. Okay. This whole thing. Then next is minus for this term. This is also over. Now for this term 250 into Q23. What is Q23? This whole thing. Okay. So now substitute 1.0 G into 375 into 0.886 theta dash minus 0.886 U dash minus 0.5 V dash. Okay. That is there. That is equals to what? This whole equals to 22,000. Clear? So after substituting this one. Now in this also we have to substitute. So this is after substituting in 6. So now substitute in 7. For 7 what is required? Q23 and 34. Okay. So let's substitute for Q23 and Q34. Okay. So Q23, right? Q23 is here. So 3 into Q23 1.0 G in whole into 375 into 0.886 theta dash minus 0.886 U dash minus 0.5 V dash. 3 into this term over plus Q34. Q34 is this one. 1.2 G into 500 into 0.866 theta dash minus V dash. That is there. That is equals to what? 40.6. So just if you will put in this value in calculator and you will simplify. Okay. And you will get how many equations? 3 equations. Right? Okay. After substituting here, and these two are equal. So means you can say 4 unknowns are there. You are getting 3 equations. So once you will solve the 3 equations, right? You will get 3 values and fourth value will be equal. So if after calculating these things and just see and solving for theta dash, U dash and V dash gives, after finding from here, just equate to 0, everything is there here, theta dash, U dash, V dash. So 3 unknowns are there, right? We got the 3 equation, first substituted then in this case, then second from this one after substituting the value of Q12, Q34 and Q23. Third equation we got after substituting here Q23, Q34. So 3 equation we have, 3 unknown, theta dash, U dash and V dash. Just solve like linear equation of 3 variables. So after solving, what you will get? That as theta dash as 1.22 G, U dash as 9.71, okay, by G, V dash is 42.9 by G, right? The value of theta dash, U dash and V dash are now inserted in equation 1, 2, 3 and 4. So now substitute here. right? Whatever the theta dash, v dash, u dash is there. So let's see here. Once what is there? V dash. So 1 point. Let me show you this also. So 1, 2, 3 and 4. So first I'm substituting theta dash here. Let's see. So in one equation only v dash is there. So what is v dash value? 42.9. So finally our Q12 will be equals to 1.6 G into what is that? V dash. V dash is 42.9 by G. This G cancel. So Q12 will be equals to 1.6 into 42.9. Okay. So once you will multiply, you will get Q12 as 68.5. Just you can multiply this, you will get Q1 as 68.5. Now substitute here that V dash we got, right? So simply that Q12. Now in Q23, put the value. Let's see what you are getting. So Q23 is there, right? So sorry for this one, that is equals to, okay, 1.0 G, okay, into this one 375 into 0.886 into theta dash. Theta dash, how much we are getting? This is 1.22 by G. First term over minus again what? 0.886. Okay, U dash. U dash is how much? Just see here. U dash is 9.71 by G into 9.71 by G. After that, minus 0.5. V dash is how much? 42.9 G into 42.9 G. So just see, in all the three terms, G is in denominator. So we can take 1 by G common. So 1.0 G into 1 by G common. Now whatever this term will be there, that is what? 375 into 0.886 into 1.22 for first term. Okay. Minus 0.886 into 9.71 for this term. Minus 0.5 into 42.9. So just put this value, multiply and add subtract 1. Okay. And this Z will get cancelled. Then you have to just multiply by 1. So after doing this, Q23 will be equals to how much? Let's see, 9.8 Newton per mm. Okay. So now we have Q3. So now for finding Q3, 4. Okay. So now similarly for Q34, that is what? Q34, that is equals to 1.2 G into 500 into 0.886 theta dash. How much theta dash is there? This one, 0.122 by G into 0.122 by G. Okay, this one minus V dash. V dash is 42.9 by G. So again, just see, in both the term, G is in denominator. So we can take common 1.2 G into 1 by G after taking common. What we have? 500 into 0.886 into 0.122 minus 42.9. Just put these values in calculator. This will get cancelled. Whatever you will get this value, multiply by this 1.2. Then you will get Q34. That Q34 will come 11.9 Newton per meter. Okay. So now next is what? Here Q41 is 1 into this one. And you can say Q41 is equals to Q23. So whatever the value of Q23 is there, how much Q23 is? 9.8. So that will be 9.8. Or else in another way, you can just substitute here in equation 4. You will get Q41 value. So what will be the Q41 value if you substitute here? So Q41 is equals to 1.0 G. What we have U dash? U dash is just 9.71 by G. So into 9.71 by G. Right. So this G cancel. So almost what we have, that is same as what we have, that 9.8. That is approximate same. Okay. So this also you can say that is same. This also is the approximate value, and what we have taken that as 9.8 as approximate value. So now we have Q1, 2, Q23, Q34, Q41. Similarly, we can find the what? Tau. So tau 1, 2 will be equals to 42.8 Newton per mm square. Tau 2, 3 will be equals to how much? 9.8. Tau 2, 3 and tau 4. 1 again that will be same. That will be equals to 9.8 Newton per mm square. Tau 3, 4 will be 9.9 Newton per mm square. So now we found all the shear stress distribution, then torque from 1 to 2, 2 to 3 and 3 to 4. All the things. Okay. So that will be the final answer for this numerical. Okay. So let's see, before going to the next numerical, I'm just quickly revising that, going for one more time. So this is the figure that is given. Okay, 1 to 2 thickness is 1.6, 2 to 3 that thickness is given as 1, 3 to 4 thickness is given as 1.2, and 4 to 1 thickness is given as how much? That is 1 mm. Okay, and it's given at from this 1 to 2 at 100 mm a force is acting of that, their magnitude is 22,000 Newton, and this angle is given that as 30 degree. So we have to find shear stress distribution along all the beams, right? Means along 1 to 2, 2 to 3, 3 to 4, 4 to 1. Means Q1 to 2, Q2 to 3, Q3 to 4 and Q4 to 1. Okay. So now, so for this the sign convention is required, and for this Q shear stress distribution already we had seen this one. So this will be the shear stress distribution, that Q formula. For this already in previous video I derived, right? So that will be what? Here this d theta by dz, du by dz and dv by dz, in this it is unknown. But for what? Built in del ws by del s is 0. So this term will be 0. So only this remaining thing will be there. So that is here. Right? Now in this equation, this is the main equation that only you have to apply here for all. So now Q1 to 2 we will find. So for 1 to 2, whatever these value will be there, that we have to take. Okay. Similarly for 2 to 3, whatever this will be there. So for 2 to 3, that angle will be there. But 1 to 2, no angle. Okay. So this 30 degree you have to consider. For 3 to 4, again this angle 30 degree you have to consider. But again in 4 to 1, no. Okay. So from substituting all the value one by one, for 1 to 2, 2 to 3, 3 to 4 and 4 to 1, we got 4 equation, right? And just we assume theta dash as d theta by, for d theta by dz, theta dash, for d u by dz, u dash, and dv by dz as v dash. Okay. So after substituting these things, all the 4, we got these 4 equations. Now what? For that, whatever the beam or diagram is there, that should be equilibrium. So what we did, divided into 2 equilibrium, horizontal equilibrium as vertical and vertical equilibrium. So horizontal equilibrium equation is this one, right? Vertical equation, for the vertical equilibrium, this is the equation, right? So this is that one. So this is the 6th equation. Now just you have to, this is our 5th equation. So taking moment about 0.0. So now we fix the origin, we have chosen origin as 0.1. So take a moment about origin, or you can say as 0.1. So after this is a moment equation, simplifying you will get this one. So now we have 3 equations, 5th, 6th, 7th. That first 4 is from the shear stress distribution, and these 4 from the horizontal equilibrium, vertical equilibrium and moment by these 3. So now what we will do, we will substitute these values, okay, in 5th, 6th, 7th. So Q12 we have this one, substitute wherever Q12 is there. So in this Q12 is there, and that's all. So just substitute here Q12 value here, and in this Q23 is also there. So substitute this Q23 value also here. So here Q12, Q34 and Q23 value is required for this equation. So substitute Q12, then next Q34 this value, and then Q23. So these first 3 value we have to substitute here, right? After simplifying, you will get equation in terms of theta dash, v dash, u dash. So that will be your another equation, or you can say that as equation 8. Now substitute here Q4 equals to Q23. Just equate this one. Q4 1 equals to Q23. So just this one and this one equate. From there simplify, you will get another equation. Put their equation number 9. Next, here moment equation is there. In that again substitute Q23, Q34, simplify, you will get this equation. So that again another equation in terms of theta dash, u dash and v dash. So substitute here Q23. After simplifying this only you will get. So substitute directly here Q23 and Q34 from here. Simplify. Another equation will be in terms of theta dash, Q dash and V dash. So now 3 unknown, 3 equation. Solve linearly. You will find the value of theta dash, V dash, U dash. After getting the theta dash, V dash, U dash, substitute back here. Because here theta dash, because final answer should be in terms of Q12, Q23, because we have to find the shear stress distribution. Right. So substitute back here. Right. So after substituting the shear, in this equation only V dash is required. So once you will substitute here V dash equation, you will get the value of Q12. In this equation, substitute theta dash also, U dash and V dash. All the 3 you have to substitute here. Then simplify, you will get Q23. Next, for Q34, what you have to do? You have to substitute theta dash value and V dash value. Substitute theta dash, V dash. And for Q41, only U dash is required. So after substituting, you will get all 4 values. And those 4 values are here. In same way, you can find for tau 1, 2, tau 2, 3 and tau 3, 4 also. Okay. So here, first numerical not over. Now, the second numerical, that also is of similar type. There we had seen what? That phi angle. So here, that phi angle is given. Okay. So now, just see this equation. Okay. So for previous question, if you have any doubt in any equation to understand that how that is there, I explain though. If any doubt you have, just comment on the video which part you have, or just like suppose in equation 1 you have problem, equation 2 you have problem. So just mention, sir, how equation 1 came, how equation 2 came. Okay. Or you just contact me regarding that equation. Then again, I will explain. Okay. Now come to the numerical 2. So question is the determine shear flow distribution. So again here we have to find the shear flow distribution only. And the condition is at the built-in end condition. Means del W by del S. Again here it will be 0. Of a beam whose cross section is shown in figure. So the cross section is given. All wall have the same thickness. So this time in previous question that thickness was different. That's why I have taken this with same thickness and different thickness. So previous question was for different thickness. All the wall having different thickness. Here all the wall having same thickness, that is T, and shear modulus G. Okay, that R is given as 200. The value of R is given as 200 mm. So just see the question. So here it's given from here to here it's a 2R. From here to here up to this, that is 2R. So means what? This also will be from here to here 2R. And this is 2R. So means this also is 2R. And that is only the diameter of semi-circle. Means radius will be R, and that is given here R. And here that angle is given just as theta, where Q23 is acting. So this is the Q23, this is Q34, this is Q12. So now we are going like clockwise. Okay. So Q41, Q1, it's from here Q12, Q23, Q34, Q41. Okay. So now for all the parts, we have to again Q12, Q23, Q34 and Q41 we have to find just like previous question. Okay. Same again 4 equation will be there. Then by symmetry equate that one. Simplify for theta dash, U dash, V dash. Once you have the theta dash, U dash, V dash, substitute back in the Q, that's shear stress distribution formula. That equation what you got. Okay. So now in general at built-in, again that del W by del Z is constant. So this is our general equation that already we had seen. So after substituting again the value what? D theta dash as d theta by dz, U dash as du by dz, and V dash as dv by dz. Substitute that value. Again same, the 4 equation will form here. Gt and into, in this case, P d theta by dz will be 0. Okay. So sorry, this one. P will be minus 2R, that is given. D theta by dz is R dash. Here cos phi, that is du by dz. See the figure. That will be u in this direction. So for which one we are finding? See, for Q41. So just see Q41. Here, this is the V term. This is u, right? So here V will be there. U will be 0 for Q41. Okay. So here V is there. Q will be 0. Now that is parallel, right? V dash. So that is the shear. That with this an angle is here. So that angle is how much? 90 degree. So put here Q equals to GT into P is given as minus 2R, and d theta by dz is what? Theta dash plus du by dz, and du by dz I am writing what? Theta dash, already we had seen, right? So plus that u dash cos 90, okay, plus dv, that is dv as v dash plus v dash sin 90. Sin 90 is 1, so that's why what we have, q equals to gt into minus 2r theta dash plus v dash. That is the first equation. Similarly, you can find for q12, q34 and q23. Just see q23. q2 3. Here there is no perpendicular condition. So means whatever here angle is given, that as phi. Right. So this phi you have to take. Okay. That's why here all the term will be there. Minus r theta dash plus u dash cos phi minus v dash sin phi. Okay. So let's see again with the direction. So this is v, this is u. So along this, u is positive and v is negative. So v dash sin phi. Right. So now we have again first 4 equation, that is shear stress distribution. For that, what is required? For finding these 4 values, we required theta dash value, v dash value and u dash value. Okay, once we have these 3, we can find, you can substitute here and we will get the value of q41, q12, q34 and q23. Right. So next, again what step is there? Take the vertical, horizontal moment equals to 0, find 3 equation, because 3 unknowns are there, substitute. So from symmetry, q12 equals to q34. Right. So just see from symmetry, q12, right? This is symmetrical, right? So from symmetry, right? So q12 equals to q34. So just equate these 2 equations, right? So what you will get? That gt minus r theta dash plus u dash is equals to gt minus r theta dash minus u dash. So gt cancel, right? So after substituting, what you will get here, u dash as 0 because nothing is there. So u dash as 0. Okay. Now, so first after equating we got 1 equation. Now next what we have to do? Resolve vertically. So let's resolve vertically. Okay. So after taking q4, 1, 2r, this is for that semicircular part. Okay. That's why, and that will vary from where. If semicircle is there, means if that phi value will start from here, then it's a from here, right? From here, this is 0, like this it will move. This is pi by 2 and up to it will move. So pi means angle is varying from 0 to pi. So that's why integral of 0 to pi q23 sin phi into r d phi. Okay, this we have to integrate, and that is equals to 20,000. It's a given. Okay, so now q41 minus that, after just simplifying, right? This 2 are divided this side. Okay, I'll just see. So here, okay, so just see. Sorry. What we have, q41 into 2r, okay, equals to 0 to pi q23 sin phi into r into d phi equals to 20,000. Take this 2r this side. So q41 equals to 0 to pi q23 sin phi r d phi equals to 20,000 by 2r. So this is cancelled. That is 10,000 by r. So q41. Okay. That. Okay. So now just see here. This minus term is there. Means for taking 2r common, r is here. So you have to take 1 by 2 also. Then only you can take 2r common from first these 2 terms. Right. So that's why here 1 by 2 term is there. So now what we have, q41 equals q41 minus 1 by 2 integral of 0 to pi q23 sin phi d phi equals to 10,000 by r. Now we have q41, right? Okay, substituting from equation 1 and 4 gives. Substituting from equation 1 and 4, right? So we have this one, 1 and 4. q41 equals to q23, just to equate that one. Okay. After that, after equating, you will get this value, that minus r theta dash plus 1.79 v dash equals to 10,000 GTR. Okay, after just from this two equation, right? So now we have three equation again for theta dash, v dash and u dash. Already we got 0. So now only two equation required. Just solve for those two equations. So just see here. Okay. Now taking moment about O. Right? After taking moment about O, Q force, that is Q for 1 into 2R, force into perpendicular distance. What distance is there? 2R. So force, that is stress into area into that distance. So Q T4 TR plus for Q12 into 2R, that is area, and into R is the distance for Q12. Similarly, for Q34 into 2R is the force and R is the length, that perpendicular distance. And for Q123 0 to pi Q23, okay, into R, that already is given, and that distance as R, right? So R and R becomes R square d phi, that is equals to 20,000 into 2R. From 20,000 distances to R, right? So now simplify this one. So first multiply and simplify. After simplifying, what we will get? 2Q41, because just here 4R square is there. So we can take 2 as common. Okay, so 2Q41 plus, just see, with every term R square is there. Okay, so that we can take common. Okay, so after taking common, we can just divide or just rewrite. So after taking R square common, or just take 2R square common. Okay, I'm taking 2R square common. Right. So here, what is that Q41? 4R square. So here this will be 2Q41 plus here Q1, 2, because 2R square we have taken common. Then plus 2R square is common. So what is left? Q34 plus Q34. Now see here, R square is there only. Right, with this term. But what we have taken common? 2. So that becomes plus 1 by 2, 0 to pi Q23 d phi, that is equals to 20,000 into 2R. Now just divide this 2R this side. So just this whole thing, and here this will be 2R square. So this 2R and 2R cancel. What is left? R. So that is here next. Q23, that is 20,000 by R. Okay. So now this one. So this is, yeah. Substituting equation 1, 2, 3 and 4. Again, substituting from here just like previous numerical. Substitute 1, 2, 3, 4 in these equations. Okay. Then you will have the equation what in terms of R, theta dash, V dash and U dash. Solve for theta dash, V dash, U dash. So after solving this equation again will be there. Solving equation 5 and 6, you will get what? In terms of R theta dash, here you will get V dash. Once you have V dash, substitute here, right? You will get R theta dash value. You have to find the theta dash, then just divide it by this R square. So now you have theta dash, V dash and U dash already is 0. So substitute in all the 4 equations. So first equation, right? First equation, where is that one? Here. U dash is 0. So in which only U dash is there? See the equation, right? Here, wherever the U dash is there, just write that as 0. Simple. So after substituting the value, Q41, you will get this one. Q12, this one. Q23, this one. Right? So just after substitute, just see here, this Q23 again minus this sign will be there because phi angle is not given the value. In previous question, that angle is given, that 30 degree. But here simply they given as phi. So in terms of phi only, we will get the answer. And that phi will be only for 2 and 3. Right? So Q12 and that is equals to Q34, 10.3 Newton per meter. Q41 is 42.8 Newton per mm. And Q23 is 10.3 minus 22.2 sine 5 Newton per mm. Okay. So now we have all the 4 values. So just let me recall once again. So for both the equation, what we have to do? First, write the shear flow distribution main formula. Right? After writing, the main formula, right? This formula. Replace that d theta by dz, du by dz and dv by dz are theta dash. So this one theta dash, for this u dash and for this v dash. Okay, just replace. And after that, from q, find from the figure what is the value of p, then cos phi and whatever is there, that area. Okay, substitute with the sign convention, proper sign convention. So after putting the sign convention, because here 4 beams are there. If suppose 5 beams are there, like here 1, right, 1 to 2 1, 2 to 3 2, 3 to 4 3, 4 to 1 4. So total 4 arm is there. If suppose 5 arm is there, 6 arm is there, that also, or 6 wall is there, then here you will have 6 equation. Whatever the number of walls is there, that many equations you will have, right? So these equations, so here 4 wall in both the equations, so that's why we have the 4 wall. Now what we have to do, first we have to find theta dash, v dash and u dash. After finding theta dash, v dash, u dash, come back and substitute in those 4 equations. If suppose 5 is there, then substitute in those 5 equations, right? And just simplify, you will get the answer. So how you will find theta dash, u dash? By moment, that resolving vertically, horizontally and taking moment. That's all. So here is the one equation. With this you got u dash as 0. And after that, once you have u dash, now only 2 things are remain, that is v dash and theta dash. How we will find the theta dash? Just here, resolving vertically. So with vertically, after resolving, you got this value, right? So from here and from 1 and 4, right? This equation is coming. So after solving this equation, right, here, after that next equation is taking moment, that vertically, horizontally and moment. These 3 you have to take. Solve those 3 equations, substitute back in 1. So just see, substituting equation 1, 2, 3 and 4 here, right? Wherever the q2, 3, just see here, q2, 3 is there, q1, 2, substitute back. So first just see here, what you have to do, this one you have to remember. So after getting these 4 equations, okay, then take the vertical equilibrium, horizontal equilibrium and moment. In that 3 equation, that 3 equation will be in terms of this only. Why? Because moment is force into perpendicular area. So force will be shear stress into area. So in shear stress term will be there. So first you have to replace Q412 these values with this one, wherever you will have. And after that, again you will get the 3 or 4 equation. Solve that 4 equation depending upon the unknowns. Find these values, the unknown values, and substitute back in this one. So let's see what we are doing. First we are finding all the 4 equations, that how many arms are there, that many equation. Next, what you have to do, you have to take vertical moment, right? Moment about that origin where what you have considered. So here we considered as 0.1. So taking moment about 0.1. The next step, vertical equilibrium should be there and horizontal equilibrium should be there. So from there you will get 3 equation. That equilibrium means wherever the torque is there, that force into perpendicular distance will be there, right? Moment, force into this one. So force will be what? In terms of stress. So stress into that area will be your force. So once you will write that equation, that moment equation, all the 3, their stress term will be there. Now you have to remove the stress term. So how you will remove? By substituting for that in particular one, whatever the particular their value is there. So for Q1, this is the value. For Q2, so wherever you are getting in the equation, like Q23, replace whatever the Q23 value is there. Okay. So here Q23 values, this one, right? So replace with that one. So now all the Q1, Q41, Q12, Q34 and Q23 got replaced. Only now 3 unknowns are there. What is that? Theta dash, V dash and U dash. So solve for, you will get 3 linear equation. Solve for those 3 linear equation for theta dash, V dash and U dash. Once you have the theta dash, V dash and U dash, come back and substitute in first 4 equation to get the value of Q41, Q12, Q234 and Q23. Right? Like this every time. Even if suppose 5 are there or 6 arms are there, 6 members or 6 walls, just find first all the 6 equation, then take the moment, consider the vertical and horizontal equilibrium. Again, in that 3 equations, substitute all, replace all Q41, whatever the shear force is there, replace in that equation, get in terms of U dash, V dash, theta dash, solve and come back and here substitute in this one all the values you will get the shear stress distribution along that particular wall. Okay, so after solving here, just Q23, Q3, 4, all the answers are there. Okay, so again this question I mentioned in the reference also, this is from the THG Maxon. Okay, so you can refer that one if suppose still any doubt you have for forming the equation or how to solve the linear equation or anything related to these equations what we used. Okay, here only one thing you have to remember, first 4 equation you just found by the what shear stress distribution formula, that main formula. After finding that, take the moment about one particular point, that what you have taken as reference. Then next, consider vertical equilibrium, horizontal equilibrium, right? So after considering these 3, you will have 3 equation in terms of shear stress. Now, what first 4 equation you have, replace those values of that shear force in the next 3 equation, that is in equation 5th, 6th, 7th. Okay, then all the shear stress will get removed. Only you will have in terms of theta dash, u dash, v dash. So 3 unknown, 3 equation. Solve for those 3 equations. Okay, then you will get theta dash, v dash, u dash. Substitute back in the shear stress value. That's all you will get. But still, if you have any doubt, you just comment on the video or you can just contact me for the doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.